I've started the recording and had some good questions throughout most of my classes. When I record, I'm recording what you see here on the screen, but it's on a separate screen. So I'm not recording the Google Meet actually. And I, during classes, I record my voice and your voice. But I don't record the actual Google Meet screen. So there we go. That's just good to know. Here we are. We're in our lecture. It's September 7th, and we're going to go over a bunch of stuff. And remember, the stuff is on the main bar. So let's take a look at it. So we're really talking about site work and soil. And I'm not sure if that gets any bigger if I that's a little bit bigger. You can see it a little bit better. So we're going to be talking about site work and soil. Last week we worked on what goes in the soil, basically the trenching and the pipes and the electrical lines and the gas lines. And we only talked about a few of them. We didn't talk about data lines or um, um, gray water lines or some of the other things that can be there. If you're in a commercial plant, lots more stuff. The hydronic lines go underground and things like that. But basically, we know stuff gets buried and we have to have drawings that tell us where. But now we're going to talk about the soil itself. So that's what this work is about. Site work and the soil itself. And you don't think about it, but the ground you build on is really important. There's the Millennium Tower in San Francisco. I don't know if you guys follow that. I do. It's a 45, 50-story tower, so it's not super tall. Um, and it's built right, right on the bay, and it was over its entire life supposed to sink about 6 inches in 50 years. And in the first 6 years, it sunk 14 inches and tilted to the right 7 inches. So they've been doing work to try to shore it up because there's no piles down to bedrock. So now they're trying to put in piles down to bedrock, and it's made it worse. Now it's to 20 inches and deep sink and about a 20-inch tilt at the top. So it's not going to fall over yet, but if I was a building near it, or if I was one of those occupants that paid $1 million for a couple thousand square foot penthouse with, 20,000 a year in fees and payments for maintenance, I'd be a little upset. And it's because they built it on quicksand, basically. So your soil is really important. And that's what most of this is about this week. We've got our 2 lectures, and I'll put the recordings there when I have them done. The playlist is pretty short this week. You'll see that it's really just the compaction elevation calc. So last week you figured out, some areas and some volumes, and there was a number here for how high it was. But now we're going to compact it to make it strong enough to hold up the building. And that's important to us to know how much that elevation is going to change. So we'll do a little bit of work with that, and then I'll be posting the lectures here. Not so much in there this time. So let's see, I think I was over here. Your reading list, I want you to go back and review slides 1 through 6. It's always good to go back, do a really brief review just to kind of remember what it was. Too often we did our week's worth of work and then we forget about it for another 2 years until you need it again. And so I'm asking you to go back and do it. But really, I want you to preview slides 7 and 8. And that means look at the headings, try to pick out bolded keywords, look at the pictures, see what they're about, and then follow the links and do the same there. And then the Caltrans best, so let's take a look at that really quick. I think I had it up already. I had it up over here. So, and you're supposed to look, so, check those out and make sure. Remember, our utilities were about what was mostly about what was underground or would be crossing the property. And so this would be on the property, but it's still good to know where it's all coming from. So there's the water. We talked about gas. We talked about electricity. Now we're going to talk about grading. And that's not the kind of grading that I do when I look at your papers. Grading is change in elevation, topography, slopes, things like that. And so, mostly it's done so water flows away from important structures and towards off-site purveyance. So you might write down the word purveyance and say, what in the world does that mean? And you'd go look it up. And then you would see traffic, access, landscape, stormwater pollution prevention plans. This one really should be bold also. I'm going to make that one bold. ADA is very important. And then we'll go off to each one of these and look at those too. So that's what, and we'll do that in a little bit more detail after I've kind of gone through everything. The Caltrans best practices, you've read this now and you looked over, I think, sections 1, 2, and 3, pages 1 through 11. And now you're going to look up something called SS2, SC1, NSA. You're going to look those things up. So there's SS2. I can go to page 11 and look that up and just see what it is. And you can do that for the other ones too. Because you've read all this. I'd like you to buzz through it again. I'm almost there. Oh, it's temporary soil stabilization. It's part of soil stabilization. And it says SS2 is a best practice that says, where possible, preserve existing vegetation. And this tells you where it's important. And then some key points. Prior to clearing and grubbing. Yeah, I can see somebody go, I don't see any existing stuff because somebody went through with a bulldozer. So that means that you have to mark it in the existing and the demolition to make sure that they don't demolish it. Okay, layout should be clearly marked with a temporary fence. There's a temporary fence. If they show it, if you didn't know that orange thing was a temporary fence, you'd never figure it out. Okay, training. You have to train people. And then there's stuff about tree preservation. And then there's some more. So these are actual instructions that with a very short term, BMP SS2, if you just write that on your drawing, it requires the people to go look this up and make sure that they understand and do all this. So that's really cool. And so I just picked a few. I picked a few different types that you might look at. Okay, so that's that one. And then there's also a Jamboard here that I'd like you to read. We're going to talk about it in a few minutes. We'll talk about it now to help you out. Okay, but after I've talked about it, I'd like you to go back and really try to understand it. So here's a building pad, and it's usually a little bit bigger than the outside of your building. And the foundation is going to get poured over some part of the building pad. So this might be concrete, it might be dirt, you might have dirt, you might have dirt all out here. This might all be dirt. Okay, and it might be right up to this elevation. But this area here has been treated and made just right to hold up the building. Now let's take a look why. Each arrow here represents part of the weight of the building. It's a force, and it's called a distributed force, but you can imagine, the building consists of the walls and the things that go in the building and the roof and the trusses and the air conditioner. So there's lots of weight that gets spread out. And if this is a raised floor, all the stuff that the floor holds gets transferred out to this part. And we're going to talk about that in a week or two when we start talking about floors next week, actually. So the whole weight of the building is usually carried along the outside or the foundation. Sometimes there's other things called piers, but all that weight comes down and it's spread around the edge of the building pad. So you have to compact, and usually they compact the whole thing, not just the edge, because it's hard to compact just a little area. And they'll usually compact on both sides, like outside of it and inside of it. And they're going to compact it so it's strong enough to hold up the building. And we don't think about that. We just, oh, yeah, there's the dirt. But with that Millennium Tower, it's really obvious. Leaning Tower of Pisa, it's really obvious. My house, it's really obvious. They put an addition on the house, and they didn't check the soil. And the addition, where the back side of my house has the second story, it's at about a 3-degree angle. If I put a marble, it just rolls right on down. It's pretty significant. That whole outside of my house is sinking. And I'm not going to freak out about it, but someday I'm going to have to jack my house back up. So your soil has to be compacted to be strong enough. Now, the way we figure out what strong enough is, I'm going to say, let's pretend that the weight, there's always a foundation and it's kind of like a certain width. I'm going to say it's 10 inches wide. And that this whole outside perimeter is 1,000 inches long. That's like 9 feet by 9 feet by 9 feet by 9 feet or so. Actually, a little more than that. But we're going to say it's about 1,000 inches long. And so that means that the total load has to be spread out over 10,000 square inches. 10 inches wide times 1,000 inches long, that's 10,000 square inches. So my total load has to be done over that. So if my building weighs 10,000 pounds, then the pressure on the ground is going to be 10,000 pounds spread over 10,000 square inches. That's 1 pound per square inch. So you have to compact the ground to carry 1 pound per square inch. Well, I'm just using these numbers because they're easy to figure out. Most dirt around here, if it's just kind of the dirt we're used to going out into a field, most dirt in the valley can handle 5 to 15,000 pounds per square inch. That's pretty good. They'll compact some and sink some, but they can handle that. Rock can carry a ton. Just a simple piece of concrete can usually, sorry, not 1,000, not 5,500. But you can look these numbers up. 1 pound per square inch. That's what we just calculated. You don't have to know the numbers. You just have to know that you will compact to whatever the geotechnical engineer says is the best that it can be compacted. And then the architect will look at that number and will calculate the weight of the building and will make the foundation wide enough so that the pressure of the building will match the load carrying capacity of the ground. Like, are you kidding me? That's what architects do? Yes. Architects do all that. They do more than just laying out pretty buildings. Of course, if they don't lay out a pretty building, nobody will hire them. But a big part of what they do is this interface to the ground, where they adjust this number by virtue of how they design the foundation to carry the weight of the house. Well, that's a good thing for the environment, because otherwise they might use way more trusses than they need just because they think it's cool and it's heavy duty and it'll never fall down. But more trusses means more weight. But it also means, what happens if you've got a shingle roof, which are very light, they're asphalt shingles, and you go, oh, I sure like my neighbor's roof. It's that beautiful clay tile. I'm going to add clay tile to my roof. And not only that, over here I'm going to put some solar panels. You might have just doubled or tripled the load on the ground. And so you can't just go put up whatever you want. You have to recalc it, and an engineer or an architect will do it, and you have to submit it to the city. So there's lots of things that we don't always think about. The materials on the roof, when you change them, are a big deal. And they're one of the biggest deals. If you put all of a sudden tile on your floor where it was a very lightweight floor, have you just added thousands of pounds to the floor? Did you put a water bed in this corner? You just added many thousands of pounds to the load in that corner. There's lots of things to think about, and you want to just step through this and make sure it makes sense to you. Okay? And it's pretty basic arithmetic. I'm not even calling it math. It's 10 times 1,000. That's 10,000. 10,000 divided by 10,000, that's 1. And so that's how you get to it. And so see if you can keep that in mind and remember those things as you go. So that's your reading list. Okay, you're also going to do a little bit of work in Revit again. You're going to put these elevations on here and these little labels. Okay, now one thing, please remove these. I know I didn't do that on mine, but please remove those when you do your work. And we're going to talk about these more later. And then there's drainage. You can see that most of the drainage goes down to this low point, right? That's the slope. So if you were a little bit of water over here, you'd go that way. Unless you were on this little backside over here. So that would say that the landscape or the civil person would have to figure out a way to redirect this water over till it got over here. And they would probably put in a berm or a little ditch, a swale, or something So any water that came this way goes back to their drainage point for this site versus going over and bothering the neighbors, whatever is over there. So this is drainage. That's important. And here's that stormwater pollution prevention plan stuff. Okay. And one of the ones, I don't know, did I call out TC1? I don't remember if I called out TC1. Yeah, I called out TC1. So that's a really important one. TC1 realizes you're going to stabilize the construction entrance and exit. They realize that one of the biggest ways that dirt and pollutants get off this site is on the wheels of the vehicles that go in and out. So you can do some very simple things at the entrance and exit to kind of knock the junk off of the wheels before you start driving around on the parts of the road that you're trying to keep clean and keep garbage from getting off of this site into the public areas. And I'll show you how to do all of those things. I actually think I have some videos to put in there. I think I've done them already. So now I just have to go find them. Okay, so those are your kind of things to see and do and read. There are, again, some discussion postings. And here, I'd like you to actually get in and do this time. Okay, you all have a Microsoft account already. You can get into it. And I'd like you to go into this and just practice and do these things, because we are going to be constructing in Minecraft later on. So I want you to go through this tutorial and actually do it. And you don't have to do the badge registration. Just go ahead and do your thing. Okay? So those are your things to do for discussions, for simulations. For your skill development, we've got this thing called compacting dirt. And I've done this little thing to make it easier for you to see. I'm going to make it a little bit bigger. So this is what we've had before, and you've already done these types of calculations. So that should be very simple. It's already there for you. But now we're going to compact it. And the geotechnical engineer will tell you how much to compact it to get the best strength. Believe it or not, more compaction does not always mean more strength. It's very weird. And you're going to see there's something called the Proctor test to make sure that you've compacted it right. Okay, and it depends on the makeup of the soil and all this other kind of stuff. So you're going to compact it what the engineer said to compact. Make this just a little bit bigger. There we go. And so if my bulldozer came through, okay, and we made this building pad, and you're going to see in your reading that making the building pad is not always easy. Sometimes you have to add soil or colloids or gravel, and the gravel has to have a certain percent of this size rock and that size rock, and you got to mix it. So it can be a lot of work to make this building pad. But we've done it, and the person has graded this area. The bulldozer has come in, and it's graded, and now it's 16 feet, and I've really kind of made it good, put all the stuff in down to 11 feet. So how deep is that? It's 5 feet deep. So I'm going to compact it 4 feet. Now watch what I'm going to do. I'm going to move this one over. And I'm going to, just for myself, say, what is that depth? It equals 16 minus 11. 5 feet deep. So I'm going to compact it how much? And you're welcome to do this. Change is the depth times my compaction. And you can get good at all this stuff and do neat things. That's my depth. So the change is going to equal, I just typed equal, the depth times the compaction. That's kind of cool. 4% of 5. I got it. That's cool. So that's how much it's going to change. So my final is going to equal my start minus the change. By the time I'm done compacting, I should be down to 15.8 feet. And that's actually what they do. They compact, they put the compaction all over it, and then a surveyor goes out and goes, nope, you're at 15.9. Compact. And look, sometimes they can use one of these little hand compactors, and sometimes they got one of the big rollers. There's tons and tons of interesting stuff about compaction. You just need to know that compaction exists. But look, here's what's cool about Excel. Copy. Isn't that just great? I just love it. Just keep going down as I go. Okay, so I only have to do it once. But I like to break problems apart like this. There was a very famous philosopher named Descartes who basically codified our current methods of scientific endeavor. And that's what he said to do. Take complicated problems and just start breaking them into things you know how to do and see if that leads you to the process of getting your final result. So I knew that it would have something to do with depth, so I calculated the depth. And then I kind of figured this one out. The change is the depth times the percent of compaction. So that's the change. So my final is my start point minus the change. Okay, so that's how you do that one. And I know I'm just kind of lecturing, but if you guys have questions, let me know. You can get into that. And now I just want to look at the submittal template kind of quickly. I'll mostly do most of the demonstrations tomorrow. So people were doing a pretty good job with these. I made some comments. Remember to turn these green when you've got them done. Okay, so remember to turn those green when you're done. And put pictures here. Some people forgot to put their pictures from down here up here. And I'll tell you, that's called an executive summary. And that's the type of thing that supervisors like to see at the end of the week, so they can get a very fast view of what's going on without looking into all the details. So this is some sort of job training like stuff. So remember to put your visuals up here. And if you didn't, I still gave you full points, but I circled it and made it like yellow. In a week or two, the full points will go away. You know, I get it. The first couple of times you're just going, oh, okay. And if you go, oh, well, he noted it but didn't mark me down, I don't have to do that anymore. Um, Wrong. Um, but I always want people to have the chance to do better the next time and the next time. So after another couple of weeks, you will be marked down if this is not completely filled in. If this is not completely filled in, if these are not filled in, and this is not filled in. So this time I just sort of did some markups. Probably just do markups this week, but in more depth. And starting next week, start taking some points off for it. Okay. Same thing here. I'm looking for you to put what you studied and the link here. Many of you did that, but some of you just put the whole link right here. So what you're intended to do is say, oh, here's what I did. And you go paste without formatting. So that's what I read. And then you put the link on. There's the link button. And then if you have too many of them, you just get rid of them. There we go. And then you can, do some more work if you feel like it. Make them really, the better you can make it look, the more cool it is. And then take some images from your study work. And so if you've got 4 things that you were supposed to read, you put 4 things here. But look, this one has stuff in it. You really have 1, 2, 3, 4, 5, 6, 7, 8, 9 things to read. Now, maybe you don't read them all, but I'll also be looking to see if you're showing that you went and found the links. Now, you could put some of the sub information out here. Just be clear to me that that's where it is. Okay, so that's another little item about those. Okay, and then here I'll be looking to see that you did watch the demo video. What was it called? And a link to it, and the name of the file, and the link. Okay, so we'll just build up our skill in being able to do these. They're going to look kind of like this for the first 6 to 8 weeks. So we'll just slowly. I very rarely did I take points off for the things that I just talked about, but I will start taking points off as we move forward. Okay. And I still have a little time, so let's go look at the production. It's a new type of drawing this time. And this is all about soil and treatment of soil and drainage and all that kind of stuff. And this one's about something called a vegetated swale, which is kind of cool. And they're pretty popular. And so it's just good to look at this and see what these things mean. What does that mean? And wow, look at that. Hardwood bio OC, Orange County. I don't know. There's all sorts of things on here that maybe and I mean, what's an invert? What's planting media? You might not even know what a swale is. Because it's kind of a new term. Ooh, temporary erosion control fabric. Diamond pattern. Anyway, all kind of interesting. And you can look it up and just talk about things that you do or don't know. Look at how cool they make this so that the stuff stays there. They have a special way of putting in the anchoring the blanket even. So there's about a 30-page book on how to design these from feds. I think it's EPA has it. So this is kind of cool, and just do your thing where you post a little video. Those are really kind of cool to be able to listen to you talk. And the workplace preparedness now is just a little bit different. Here is a job called a planning assistant. And it's interesting to see what they do. And so the reason I picked this one up is about reading specifications, construction documents, maps, stormwater pollution prevention plan, compliance. So this might not be what you're interested in, but there's a lot of cool stuff in here that read and interpret plans, site plans, specifications, spreadsheets. These are all things that we're going to go over as we do this. But look, this isn't bad. You know, that's not bad, and that's out there right now. It's temporary, which is a bummer, but that's, you know. Construction technology, that's us, by the way. Okay, associate's degree. So we meet that one. We're in the preferred thing if you get one of our degrees. So now these, you know, they're asking for a bunch, but gosh, you're learning some AutoCAD, you're learning some SketchUp, you're learning some Revit. So that's what I'd like you to do. Okay, look that over. Now, some of that is what we do. Some of it is other stuff. And if you said, that's what I want to be able to do, I want to be a planning assistant and I want to be able to work outdoors and do all this kind of stuff, and that sounds pretty cool to me, you might think about what else besides Design 300 that you might want to take. And you can even look in the catalog, and the catalog will take you here, and then you have to go to this. And just look around, say, who knows? And then just let me know. Yeah, you know, that looks pretty cool. I think maybe I'll go to landscape architecture. Or that looks pretty cool. Maybe I'll just do your system and go get a job. Or, you know, that SWPPP thing and that certification, I wonder how I would get those. Might not even be able to get it here. You might have to go somewhere else. So this is all just part of thinking things through. Hopefully it'll take you 15 or 20 minutes, 30 minutes to look that one over. Okay. I think I've done the preview and going over things and what you need to do and all that kind of stuff. So I'm going to answer some questions. And as an example, I'm going to be here in VMware. And look, VMware is always quite an interesting thing because it's showing up on your computer, but it's not on your computer. This is actually remote access to a computer that is at American River College. And not only that, it's not even in a physical computer. It's in this big server room, and it's virtual. It's truly virtual. And so they just load up an area of the server to look exactly like a computer. So this doesn't exist in the real world, and so it won't talk very well with the real world. So we need to be able to do that. So what I'm going to do is I'm going to move this all out of the way and bring just my VMware up here. And I'm going to turn off my bookmarks. So now it truly does look, I'm just working in VMware, except for down at the bottom. That very bottom is my toolbar from my computer. The black one is the toolbar from the VMware. Now, to get out of VMware, there's a few things I can do. I can go to this little Windows button, and I can click. Oh, I can come up here, and I can say sign out. That's one way. But what I usually do is I just go up to my back button, and I click out of it. But then I have to do one more thing. I actually have to get out of VMware. That just took me off of my portal. Now I'm going to get out. Now, if I don't do that, it can think when I go back in again that I'm already in there and it'll get all confused. But that's okay. You can always, from wherever you happen to be, just click this button, and it may all be showing up over on the side instead. Click that button. Click the button that says, I want to log out. And then you'll really, really, really be out. Okay, so here we go. Now I'm going to do the next part, which is my get started. Now, I have an advantage here. I've got one screen that's my laptop, and I have another whole screen all to itself that is my VMware. So that's kind of cool. Everything you see up here, that's on a whole separate screen, and I have my other screen happening down below. So my setup is pretty nice. If you have this all on one computer with just one screen, I totally understand how hard that is, because I did teach for a week using nothing but a Chromebook just to see what it would be like if that was where I'm at, because that's where a lot of our students are at. And I get it 100%. It's complex and it's hard to do. But here I go. I've got all this open. The first thing that I always do is open Google Chrome again, because the Google Chromes at the bottom don't talk to anything going on in VMware. Okay, so I'm going to close everything up that's in my current VMware. So all I've got is standard VMware. So I'm going to go to Google Chrome. I'm a Chrome user. Sorry. I love it. And I'm going to log in. And I do two things. First, and see how I right clicked? I do it in a new tab. So I open my Google Drive and I open my Canvas. And of course, from Canvas, I also usually turn this thing down so I've got a little bit bigger screen. And now I can get to the work that I need. And what I want to do is I want to download that file. There it is. Now here it is. It's in my VMware, sitting here in my download. So I need to put it somewhere safe. So I'll go to my PC. And you should all, excuse me, have a W number drive, your U drive. Excuse me. And I'll get rid of these two. And I'm just going to make one called week 3 or something like that. Open it up. And I can just hold my left button down and drag it in. Now I've got it and it's saved for me. So I'll minimize this work. Now, if I open it up, it should use Revit to open it up, but computers can get kind of confused sometimes. So I like to open my program first. There's another thing I open first, usually, which is Adobe, and that's so I can do PDFs, but I'll do that another time. And so here it is. It's opening up. And I can make it full. And now I'm going to go open a model. That's what I'm going to do. I'm going to open a model. And it'll ask me to go look for it. Let's see. My computer, my drive 300, week 3. There it is right there. Open it up. And once it opens up, I'll be ready to work. And I'm going to show you next on Thursday how to do all the work. Okay, but you can see there's places for me. Drainage, stormwater pollution, topo. Those are the 3 that you're going to work with. And you're just going to go about making them look right. Okay? So that is how you're going to do it. And of course, you can save and all that kind of stuff. I'm not going to bother this time because I'm going to demonstrate it on Thursday. But I think I've done some videos. I'll have to go back and look for them to see if I've done the videos and if I should post them. Okay, so there we go. So now to get out of it, I'll close down all my programs. I'll go up to the little top arrow button. This is my preferred way of doing it. And then I'll do this one. And then it should let me back in. Sometimes it gets confused and it goes, oh, you're already, it's unsafe, or you've been disconnected, or whatever. Just find a way to exit out and get back in again. Okay, now I need to put my work back up. There we go. And so I'm just going to ask if let me make sure I went over all the stuff. Looks like I did. Are there any questions before I let you guys go and just start working?
For the convecting dirt assignment, it's stuck on view only. Is it supposed to be like that?
Yes, you need to. I should have made it to make a copy. Hold on a sec. Let me. Yes, you need to make your own copy of it. I thought I had done that. Let me get in there and do it right now so that it does make a copy. Where's my edit? There we go. This one right here. Oh, yeah, I see that I left it as. Usually I change that. Okay, give it a quick try. You may have to reload, but that should do it so that it will open up and make you make a new copy. If you ever do get stuck in one that's that way, you can go to File, Make a Copy. That's what I just made it automatically do. Okay, that was a good question. Thank you for um, allowing me to correct that. Are there any other questions? Cool. All right. Well, then that's that. I'm going to go ahead and log off and get ready for my next class. So I'll see you all on Thursday. Bye.